So, hello everyone. Now let's move on to the application and analytics section where we look at how these concepts are actually used in the real life and when it's time to explore the apps, websites, or automation application, it will help us understand the practical use of these technologies. So, let's start and explore how these ideas are applied. So next question is, no single ML algorithms performs best on all the problems, and this refers to which theorem? So this theorem uh, is named as no free lunch theorem, and this simply says that no algorithm is perfect for all types of data sets. An algorithm that works amazingly well for one problem might perform very poorly on the another. Next is the method that uses smaller training subsets repeatedly to estimate test error is known as. So this method is known as cross validation method. Uh, Cross validation is a technique where we split the data sets into smaller parts and keep rotating the training and the testing sets. So this gives a more accurate and stable estimate of the model's performance. So this basically used for preventing the overfitting because the model is tested on multiple combinations of the data. Next is in KNN, runtime grows with O or N, where N is the number of points and D is the number of dimensions. So in K nearest neighbors, it basically compares the new point with every existing point in the dataset. So if the data has n points and each point has d features, then the algorithm must check all the endpoints across the d dimensions. That's why KNN becomes slow for large datasets or high dimensional datasets. So the answer is big O N D. Next is the curse of dimensionality affects algorithm that depends on dash metrics. So the answer is distance metrics. In high dimensional data, distance between points becomes less meaningful. For example, in Euclidean distance, that doesn't differentiate points well when features are in larger number. That means features are too many. So algorithms like KNN or clustering or SVM, which rely on distance, face some of the problems. So this effect is called the curse of dimensionality effect. Next is uh, PCA transforms correlated features into dash components. So PCA, that is principal component analysis, transforms correlated features into uncorrelated components. Here, uncorrelated components are formed from the combinations of the old features, but they do not overlap the information. They becomes just independent. This helps reduce redundancy and makes model faster and more accurate. Next is the process of mapping words to numerical vectors in NLP is known as. So it is known as embeddings. So machines cannot understand text directly, so we convert words into numbers, and word embeddings are a way to represent words as meaningful numerical vectors. Let us understand this with an example. Queen and king will have similar vector values, but king and banana will have different values. So this helps model understand that relationships between the words. Next is in neural network, removing random neurons during training is called. So it is called dropout. Dropout is basically a technique to prevent overfitting in deep learning. During training, some of the neurons are turned off randomly, and this forces the network to not depend on only a few neurons. It makes the model more general and robust. Think of it like practicing with one hand tied or become stronger overall. Next is Spark uses dash RDDs for fault tolerant distributed data storage. So it uses resilient distributed datasets, that is RDDs. distributed, which is distributed across many machines. Fault tolerance basically means if one machine fails, data doesn't get lost. And immutable means cannot be changed once created. So RDDs help Spark process very large data set quickly through the parallel computing. Next is in Hadoop, YARN stands for. In Hadoop, YARN stands for yet another resource negotiator, and YARN is a resource manager of Hadoop. So its task is to decide which job should run, where it should run, how much memory and CPU it gets. Basically, it manages all the cluster resources so big data tasks can run smoothly on our machines. Thank you.